show you an experiment proved by adhesion and cohesion properties of water. What I have here is a glass of water. That is, you can full as you can possibly get. I mean, you can put anything in this glass and the water will not come over the top. Here I use some coins. We are going to see how high you can rise the water level until it fills up. Let's get started. Okay. Put the coin slowly in the glass. As you can see, the water level remains constant. There's 15 coins in there. I don't think I can get much more. The water starts spilling out at the right side of the glass. So, we only get 15 coins in the glass and the glass starts to full and spilling out. When it comes to the 15th coin, the water starts to spill out. This is because the surface tension has broke. As we know, the water molecule here at the bottom of the glass has too many water molecules around them, which they are likely to attract to each other. These water molecules form hydrogen bond around them and get pulled toward them. There is a term for this called cohesion. However, at the surface, there is no water molecule above them. They are free and less restricted, so that allow the water molecule or the surface to group together a little better to form stronger, tighter bonds. Closer spacing at the surface, in the other word we call surface tension.
Info Science Gate 1. Water is unusual in that it can occur naturally in three distinct forms: gas, liquid, and solid at the same time. On a winter day, you can see solid water, ice atop a partly frozen creek, and liquid water flowing in the creek. And if you look up, you see evidence for water vapor. Water's gases form in the clouds floating in the sky. Most substances contract as they freeze, but water expands. If you have ever filled a container with water all the way to the top and put it in the freezer, you know this from experience. The expanded ice cracks the container or pushes off the top. Also, a bucket full of ice is lighter than the same size bucket full of water. That's why ice floats on water.
Hi! Welcome to our second experiment, the properties of water density. I will do a demonstration to show that the cool water will sink on the hot water. The expected result is the cool green water will immediately fall into the hot orange color and cause mixing.
First of all, take the orange food coloring and put inside the hot water. And stir it slowly. Next, take the green food coloring and put inside the cold water. And stir it slowly too. Both of these to make sure that we can differentiate whether the orange for hot water and the green for the cold water. The next step is put the plastic card on the top of the green cold water. Then next, put on the top of the hot water slowly. Then what? Tarik the paper card. No, plastic card. Slowly. As what you can see, both water, hot and cool, will dissolve together up and down and mix well.
The water quickly become light green throughout. Why do you think the cool water and the hot water mix when the cool water is on the top? Their answer is, when the cool water is on the top, the color mix because the cold water is more dense and sink on the hot water. What might happen if the hot orange water is placed on the top of the cool green water and removing the card? The expected result is, although removing the card may cause a little mixing or spilling, the hot orange color will remain on the top of the glass and the cool green color will remain on the bottom of glass. Let's see together.
Now I will put the hot water on top of the cold water. Let's see together. Okay, as what you can see, the cold water, which is in green color, cannot dissolve with the hot water with orange color.
Why do you think the hot orange color remain on the top? The answer is, you should realize that there is a difference density between hot and cold water. The hot water is less
Info Science Geek 2. Water is life. It is cool on everyone's lips. Decades of research on water is giving us remarkable insights into its dynamic collective structure and changing our big picture of life and living process. Organisms are 70 to 80% water. Is this water necessary to life? Entire biochemistry and cell biology textbooks are still being written without ever mentioning the role of water. It is simply treated as the inert medium in which all the specific biochemical reactions are being played out.
Okay, now let's talk how water works as a solvent. First, we need detergent, 2 glass of water, turpentine, and food coloring. Firstly, dissolve water with detergent. Stir it. Secondly, dissolve turpentine with water. Stir it. What could happen actually? After a while, we can see the detergent do not dissolve in water. Detergent is known as empathetic molecule. It has both hydrophilic and hydrophobic properties. Let's see what happens if we dissolve turpentine in water. We can see actually turpentine do not dissolve in water. Let me show it. Here we can see it will form 2 layers.
Water and detergent. This is the result for the experiment in the previous video. When water dissolves with detergent, we can observe some molecule of detergent dissolve in water, while some molecules do not dissolve in water. Detergent have hydrophobic or water-hating molecular chains and hydrophilic or water-loving component. The hydrophobic hydrocarbons are repelled by water but are attracted to oil and grease. The hydrophilic end of the same molecule means that one end of the molecule will be attracted to water while the other side is binding to oil. Next, let's talk about turpentine and water. Turpentine. Turpentine molecules are basically long hydrocarbon chains and these are non-polar molecules. The picture shows the molecule with carbon backbone and hydrogen atoms coming out of the backbone. Water. Water, in contrast, is a polar molecule, where the electrons are closer to the oxygen atom than the hydrogen atom. And the molecule is bent so that both hydrogen are to one side. The hydrogen end is positive and the oxygen end is negative. This is the reason that water is liquid at room temperature, even though hydrogen and oxygen are gases. When we dissolve turpentine in water, we can see turpentine at the top of water. The turpentine and water do not mix together because turpentine is made up of nonpolar molecules, while water are polar in nature. Because water molecules are electrically charged, they get attracted to each water molecule and exclude the oils molecule. This is eventually cause the turpentine to clump together.
Info Science Geek 3. Water is simple. There is nothing simpler than water as a molecule. Its chemical formula, H2O, is almost the first thing in the chemistry that one learns in school. However, its structure in the bulk is multifarious and changeable. There are 13 known crystalline structures of ice that appear under different temperatures and pressures. As a liquid, water forms dynamic flickering clusters or networks of joined-up molecules, with the intermolecular bonds that flicker on and off at random. The basis for all this complexity lies in the ability of a water molecule to join up with its neighbors through a special kind of chemical bond, the hydrogen bond.
Now we will show you about the thermal properties of water experiment.
The apparatus that we need are a glass of water, 2 paper cups, thermometer, and a burning candle.
Okay, now let's proceed to the procedure. First of all, take an empty paper cup and burn it on the burning candle. It's burning. Next, put the water into that empty cup. The initial temperature of water is 32.6 degrees Celsius. Now, take the cup of water and burn it on the top of the burning candle. As you can see, there is no burn. Okay, let's measure the temperature of the water. As you can see, the temperature rise up. Okay. Okay, that is the maximum value for the temperature.
In this experiment, the first two elements burning material, which is the paper cup and oxygen, are present. But heat is absent. How is it possible that heat is absent? I mean, heat is constantly being given to the paper cup by the burner. Well, it is because the heat given by the burner is absorbed by the water inside the paper cup. That is why the paper cup is not getting the necessary heat to get burned. And in the meanwhile, if you wait up a bit longer, the water will boil as well. If you put a direct flame to the cup, you should also be okay, as long as the paper is thin and the part of the paper cup touching flame is also touch the water. This is because objects in contact tend to equalize their temperature. As we know, water boils at 100 degrees of Celsius and it stays when you add extra heat to it. You only can change the rate at which it boils. This means the paper touching it wants to stay at 100 degrees of Celsius as well, and it transfers any extra heat to the boiling water in order to do so. This is because the water has reached its boiling point. So, if you apply a direct flame to the bottom of a paper cup filled with water, the paper should not burn. Of course, if the paper is thick so that it cannot transfer the heat from the outside to the water quickly enough, or if the water boils off, then the paper can burn.
Info Science Geek 4. Why is water so special that life cannot exist without it? According to John L. Finney of University College London, the basic tetrahedral structure of the water molecule is central to the structural versatility of water in the condensed state, solid, and liquid. It enables water to form extended, flexible networks of H-bonded molecules in liquid, allowing rapid coordinated molecular motions to take place. This same extended network also supports proton conduction, a flow of positive electricity that occurs much faster than the diffusion of ions. Other substances might have some of those special characteristics, says Finney, but only water has them all, and that might be enough to make water especially fit for life.
Hi, today I will do the wacky water photosynthesis. You take the red food coloring and put inside the hot water. Oh, oh my god!
I mean, you could put anything in this glass and the water.
Firstly, we need detergent, 2 glasses of water, and turpentine. Oh, and lupa benda Allah ni.
The apparatus that we need are a glass of water,